Okay, so here we are with Unit 8, Lesson number 1, and this is more of an introduction into the unit. If you take a look at the boxes that are here, this pretty much gives you an idea of the sort of an outline of all the topics that we're going to be looking at. I'm not going to go through that, but what I do want to point out is a couple of things. First of all, the terms that you should have know the definition for. So collision theory is something that's extremely important. You should know the definition of a collision theory. You should know what heat of reaction is. These you should already know: endo versus exothermic, activated complex, activation energy. You should definitely know the term catalyst. That's one of the top 20 terms on the Regents exam. You should know chemical equilibrium and these two terms also. So it's 1, 2, 3, 4, 5, 6, 7, 8. So there are 10 definitions that you should know by the end of this unit. So let's get into this. So what exactly is kinetics? Well, as you can see there, kinetics is defined as the study of the rate or speed at which reactions occur, how fast the reaction is or how slow the reaction is. Well, what's exactly involved during a chemical reaction? Well, if you remember in a chemical reaction, if you remember back to the definition of a chemical reaction involves the formation of new substances. It doesn't mean that different elements were formed, it just means that they've been rearranged. And the rearranging of those elements involves the breaking and reforming of bonds. And that breaking and reforming of bonds results in completely new compounds being formed. Same elements that they started with, they're just rearranged. And how does a reaction occur? Well, reactions are not as simple as we've led you to believe. When we see a chemical reaction, we generally look at just the reactants and then the final products. Now, when I say final products, what does that mean? Well, what that means is that not all chemical reactions are that simple. Sometimes the reactants, before they form the final products, will form intermediate products, not necessarily the products that we're looking for at the end. And there can be 1, 2, 3, or several intermediate products before you get to the end products, and we don't show you those because they're really not involved in what we're doing except in this particular unit. And you can see you can't really omit any steps, you can't change the order of the steps, and you can't omit any of the reactants. Now if you look at this is sort of a very simple sort of exercise in figuring out a fast reaction versus a slow reaction. And if you look at this, rusting is basically when you take iron and you leave it out in the atmosphere, it's exposed to air and water, and it rusts. And we all know that that does not occur overnight. So that's a relatively slow reaction. Alka-Seltzer in water, you've probably seen this, is a very fast reaction. As soon as you drop the Alka-Seltzer in the water, the reaction begins. How do you know? Because you can see the bubbling. That bubbling is an indication that a chemical reaction is occurring. The next two, the decomposing of styrofoam, is a very slow reaction rate. It could take decades, probably centuries, for styrofoam to decompose. And an even slower reaction is the weathering of rocks, literally breaking of rocks into smaller pieces. That takes millions of years. The final one, bleach removing color, is probably as fast as the Alka-Seltzer one. As soon as you put the bleach on something, you'll notice that the color is gone. So let's look at what actually determines the rate of a reaction. Now, this is not something that they ask you about a lot on the Regents exam. I wouldn't worry a whole heck of a lot about it. This first part is important. I wouldn't worry about this particular thing here. But what determines the speed or the rate of a reaction? Well, it basically depends on how many steps are in it. The more steps that are involved, in other words, the more intermediate products that form before your final products, the longer the reaction is going to be. So it's going to have a slower reaction rate. And you can see here that they have something called the rate determining step. If you have a reaction that has 10, let's say 5 intermediate products that form, if 4 of them are extremely fast, but 1 of them is very slow, that slow one is going to make the reaction, make it a slow reaction rate. That would be the rate determining step. Again, as I had mentioned before, this is not really something that you need to worry a lot about. And that's the end of lesson 1.